Okay, so moving on into chapter 4 here, what we're going to focus on for today is looking at solving linear equations, solving for x. It's going to be the same question over and over again. We're just going to slowly ramp up the difficulty and the complexity of the question. We've looked at these types of algebraic questions already. We did a little bit with trigonometry. We did a little bit in chapter 3 when we were solving for our y-intercept, for instance. So I just want to bring this all together and kind of consolidate what we need to do when we're asked to solve a linear equation. Now, first off, let's make sure we're speaking the same language. When we have a linear equation, there are different parts to the equation. I've made the analogy to the English language before. In a sentence, there are nouns and verbs, and we need to arrange those in a certain way in order for the sentence to make sense. Same thing is true for a linear equation. So for instance, if we have this equation, 2x plus 9 equals 1. There are 4 different items to this question. There's the 2, the x, the 9, and the 1. And they have different names to them. The first one we want to focus on is that letter, okay? The x. That's the variable. We call it a variable because what the value of x is varies. It can change. We're not sure what the value of x is. It's unknown. The 2 is the coefficient. Now, the reason the 2 is the coefficient is because it's the number in front of our variable. Okay, so when you have a number in front of the variable, 2 times x in this case, that 2 is known as the coefficient. The 9 and the 1 are not paired up with any letters, so we call those constants, because it doesn't matter what the x is in this case, what the value of x is. The 9 and the 1 always stand alone, and so they do not change. They are constant. Now, specifically, we can say, well, this equation as a whole is first degree. We say it's first degree because there's no exponent on our variable. Or actually, probably a better way to say it is there is an exponent, but if you recall, when you have a variable, there's always a 1 as an exponent. We just don't write it. Right? So we might have, say, x squared, so the exponent is 2. If we just write x, the exponent is 1, but just for formatting, we don't bother writing it. So probably a better way to say it is not that there's no exponent, but the exponent is 1, so we call it first degree, so that matches up. If we look at the second equation, if we name the parts, we can see n is our variable in this case. That's the unknown. The coefficient of n is 3. That's what we're multiplying the variable by. And 7 and 9 are our constants. In this case, it's a second degree equation because the exponent is 2. Okay? So basically, the degree of the equation always matches up with what the exponent is. Now, we've talked about this in class. When we're trying to isolate a variable and solve for x, the key here is we need to do that by the opposite operation. We saw that when we were doing our trigonometry. If we had sine theta and we wanted to solve for theta, we do the inverse sine, right? So it's the same premise here. So let's go through a couple of examples. So for this first one, we have m plus 9 minus 1. So we're thinking to ourselves, okay, we want to get the m to be alone. What is stopping the m from being alone? And it is that plus 9. So what we're going to do is we're going to subtract 9. We're going to do the opposite operation to both sides. So we'd have m plus 9 minus 9 is equal to negative 1 minus 9. Okay, so we're subtracting 9 from each side. Now when I do that, on the left, plus 9 and minus 9 are going to cancel out. So I'm left with just m. And then on my right-hand side, I have negative 1 minus 9, which is going to be negative 10. For b, negative 5a is equal to 15. So again, we want to do the opposite operation. What is stopping a from being alone? It's the negative 5. And negative 5 is the coefficient. We're multiplying by negative 5. So the opposite is I'm going to divide both sides by negative 5. So negative 5s are going to cancel. I'm left with just a. And I have 15 divided by negative 5, which is negative 3. Lastly, over here for question C, solving for x, the x is on the right-hand side of the equation, but that doesn't matter, left or right, they're the same thing. So what is stopping the x from being alone? We have x divided by 4, so I'm going to multiply both sides by 4. So on the left, I'll have 4 times negative 3. It's equal to x over 4 times 4. Those 4 cancel, so I'm left with just x. 4 times negative 3 is negative 12. Now, if we have multiple things going on, then we need to decide which one we do first. When we decide the order of operations, we of course have our acronym BEDMAS: brackets, exponents, division, multiplication, addition, subtraction. But because we are undoing because we're undoing a linear equation, then we're going to run BEDMAS in reverse. So we're actually going to take care of addition, subtraction first, then multiplication, division, then exponents, then brackets at the very end. So let's look at a couple of those. So let's say I have this one here. 7k minus 5 equals 16. So there's two things stopping the k from being alone. We have 7 and we have that minus 5. So which one do we do first? Following reverse BEDMAS, we're going to get rid of the negative 5 first. That's subtraction. Normally in BEDMAS that comes last, but because we're undoing it, it's actually going to come first. So the first thing I'm going to do is add 5 to both sides. So 7k minus 5 plus 5 is equal to 16 plus 5. So that's going to leave me with 7k on the left, and that's equal to 21 on the right. Now we can reevaluate and say, okay, what's next? Well, that 7 is in the way, so I'm going to divide both sides by 7, and I'm left with k equals 3. All right, same thing here. E, 3 is equal to 1/2 w plus 7. Now, when we have fractions like this, it can be a little tricky, but we're going to come at this basically the same way. Remember, a fraction is still a number. Nothing changes. So what is stopping the w from being alone? Well, it's the 1/2, and it's the 7. So similar to the last one, first thing I'm going to deal with is the addition subtraction. So I'm going to subtract 7 from both sides. So I'm going to have 3 minus 7 is equal to 1/2 w plus 7 minus 7. So those are going to cancel. I'm going to start speeding things along here. So I'm not going to write that down. If you would like to, you can. So we're left with 3 minus 7. So that's going to be negative 4 is equal to 1/2 w. So how do we get rid of the 1/2? Well, what we can do is just multiply everything by 2, right? If half of w is negative 4, then let's multiply everything by 2, and so that's going to give us negative 8 is equal to w. Notice whenever I add anything, I add it to both sides. You cannot just add it to one side without putting it on the other. The rule for algebra is you can do anything you want. You can add 72 if you want. It's probably not going to help you, but as long as you do it to both sides of the equation, then the equation remains true. It remains equal. Okay? So when you're doing this, you can't just write something on one side of the equation and not the other. Make sure you put it on both. Okay. Now, if we want to make sure we've done this correctly, we can do a formal check. And when we do a formal check, we're going to break our equation into left side and right side. So here is one of the examples from the previous slide. 7k minus 5 equals 16. We already solved this and saw that it was 3. So let's go ahead and do a formal check to make sure we're doing this correctly. Now, what I'm going to do is I'm going to look at the original equation and say, okay, what's on the left-hand side of my equal sign? So that's going to be 7k minus 5. And on the right-hand side of my equal sign was 3. Now what I'm going to do is I'm going to take in my value of 3, or sorry, let's go back and fix that. The right side wasn't 3, it was 16. Excuse me, the answer was 3. There we go. So 7k minus 5 equals 16. So now what I'm going to do is I'm going to go in and I'm going to plug in my k is equal to 3. So I'm going to have 7 times 3 minus 5. And let's go ahead and solve for that. So that's going to be 21 minus 5, which is 16. So you can see the left side is equal to the right side. So therefore, k is equal to 3 is the correct answer. If I got, say, 13 over here on the left and 16 on the right, then you know that we've done something wrong and that answer would be incorrect. Now this is how we do a formal check. The reason we do a formal check like this is we never want to end up with the equation. Let's say I did something wrong and I got the answer was k equals 2. Okay? So what would happen if I tried plugging in k equals 2? Well, if I just plugged it into the equation, so 7 times 2 minus 5 equals 16, well, that's 14 minus 5 equals 16, so that means 9 is equal to 16. I think we know 9 is not equal to 16, so I can never write this, right? That's wrong. Well, that means the line above it is also wrong, which means the line above it is also wrong. Everything I've written here is incorrect, and we don't like to write incorrect things in mathematics. So in order to get around that is we break the equation into the left side and the right side when we do a formal check. If I don't ask you to do a formal check, you can always check your answer by doing it this way. You can just plug in your numbers and see if it works. You can do that in your head or you can do it off on a side scrap of paper, that's fine. But if you're asked for a formal check, then I want you to break it up like above into left side and right side. Okay. Now, what if we have a fraction like this? There's a couple different ways we can go about this, okay? So I'm going to solve this same question twice. Remember, it is a fraction, and a fraction is still a number. Anything I can do with a number, I can still do with a fraction. Nothing changes. So what would I do? So 5 over 6g equals 20. So what's happening? My coefficient in this case is the fraction 5 over 6. So if the question was just 5g is equal to 20, well then what I would do is I would divide both sides by 5, right? I divide by the coefficient. Well, that's what I'm going to do here. Nothing's going to change. I'm still going to divide by the coefficient. So I'm going to have 5 over 6g is equal to 20, and I'm going to divide both sides by that fraction, 5 over 6. So on the left, those are going to cancel. As always, anything divided by itself is 1, so I'm left with just g. And then over here, I'm going to rewrite this 20 divided by the fraction 5 over 6. Now, what were the rules we learned in previous years about dividing fractions? Well, what we need to do is multiply by the reciprocal. And the reciprocal is when we flip the fraction upside down. So this is the same thing as 20 times 6 over 5. And now I can just solve for this, right? So I have 20 times 6 is 120, and 120 divided by 5 is 24. Okay, 20 times 6 divided by 5. That's one way we can do it. Now, the other way we can do it is we can actually break the fraction up and think about it not as the fraction 5 over 6, but we could think of it as two separate operations. We could think of it as times 5 divided by 6. So let's look at it that way. So I'm going to have 5g, I'm going to write this one in a different color, over 6 is equal to 20. Okay? So let's treat the 5 and the 6 differently. Okay? So for the g, I'm multiplying it by 5 and dividing it by 6. So we want to get rid of both of those. Let's get rid of the 6 first. And the first thing I'm going to do is I'm going to multiply both sides by 6. So I'm going to have 5g over 6 times 6 is equal to 20 times 6. So that 6 and 6 are going to cancel, so I'm left with just 5g is equal to 20 times 6. And at this point, I can multiply that through if I want, or I can just continue along and multiply at the end. But now I'm left with the 5g, so I'm going to divide both sides by 5. So I'm left with g is equal to 20 times 6 divided by 5. Well, look, that's exactly what I have over here. Okay, so multiplying that through, 20 times 6 is 120, divided by 5 is 24. So we can see G is 24. Either way you're going to do it. I would give you full marks for either one of these methods. It depends on what you feel more comfortable with, whether you want to treat it as one thing, a fraction. It's only one step, but you do need to deal with the fraction. Or we can treat a fraction like two separate operations. Simplifies the thought process, but now it becomes two steps instead of one. Whatever method makes more sense to you. There are benefits to both, and so depending on the question, you might want to use one technique over the other, and we'll see some of those as we go through our practice. Okay, so that's 4.1. With 4.2, we're just going to keep doing the same thing, but getting into maybe 3, 4, 5 steps. We're going to throw in some other little bits of difficulty, for instance, maybe brackets or additional fractions. So what can we do here? We're just going to go ahead. Let's jump right into an example. What if we have brackets in our questions? Let's say we have something like this. -5 times 11 plus m is equal to -45. There's two things we can do here. Now, the first thing we can do is remember what that bracket means. I have -5 times 11 plus m. So I'm multiplying both the 11 and the m by -5. So one thing we could do is just get rid of the brackets. And we could do that by multiplying through. So I'm going to multiply everything in the brackets by -5. So I have -55 minus 5m equals -45. So now that we've expanded out the brackets, we're back to an identical question we would have seen in 4.1. So let's go ahead and solve for m here. So we have the -55, that's a constant, and we have the -5, that's the coefficient. So we're going to get rid of the constant first, take care of the addition subtraction. So I'm going to add 55 to both sides. So -5m is going to be -45 plus 55. So that means -5m is equal to 10. Then I'll divide both sides by -5, and we get m is equal to -2. So that's one way to solve it. Let's do the exact same question here, but let me show you a different technique. Using our mantra from the previous lesson, opposite operation, reverse BEDMAS, we could treat the 11 plus m like a single object for now. Okay, so that's in brackets. So we're going to treat it like a single thing, and we want to get rid of that -5. Well, if we're going to treat this like one thing, let me just rewrite this question really quick. So this is like saying -5 box equals -45, right? Where box is the variable in this case. Well, how do we isolate box? How do we get that to be alone? We divide both sides by -5, right? That's what we would have done before. So that's exactly what we're going to do here. I'm going to divide this whole thing by -5 on both sides. When I do that, the -5 is going to cancel, and I'm left with just the box, just the brackets on the right-hand side. So that's going to be 11 plus m. I don't need the brackets anymore because there's nothing in front of them. And that's going to be equal to -45 divided by -5, which is +9. So I'm left with a much simpler equation. 11 plus m equals 9. So I'll subtract 11 from both sides now. I'll get 9 minus 11. So m is -2. Again, you can see the exact same answer on both sides. Doesn't matter which technique you use. I would give you full marks on both. Again, depending on the type of question, Both techniques are good. Maybe one is preferred over the other. Okay. What if we have some fractions here? Well, when you have fractions, like we talked about a lot, fractions are annoying. So one of the things we can do is let's just get rid of the fraction, right? That's the first thing we're going to do. So in this case, we have 2 times t minus 4 over 3 equals 8. Well, what makes this one a little bit annoying is that divided by 3, it's that fraction. So let's just go ahead and get rid of that fraction right away. And we do that by multiplying by whatever's in the denominator, right? We're going to multiply everything by 3. It's divided by 3. We do the opposite, multiply by 3. So 2t minus 4 over 3 times 3 is equal to 8 times 3. Again, those 3's are going to cancel, so I'm left with just 2 times t minus 4 in brackets, and that's equal to 8 times 3, which is 24. Now that we've done that, now it's the very similar question to the last question we did. So we can either expand out these brackets, or we can divide everything by 2 right now to get those brackets to be alone. So let's go ahead and divide everything by 2. And that'll leave us with t minus 4 on the left. And that's equal to 24 divided by 2 is 12. So t minus 4 equals 12. I'm going to add 4 to both sides. And I get t is equal to 16. What if we have 2 fractions? Well, if we have 2 fractions, we're going to come at it the same way. I want to get rid of fractions. So for the first fraction, how do I clear out that fraction? Well, I multiply by the denominator, so I'm going to multiply by 5. For the second fraction, how do I get rid of the denominator? Well, I'm going to multiply by 6. So I'm going to be multiplying by 5, and I'm going to be multiplying by 6. Well, if I'm multiplying by 5 and 6, why don't we do that at the same time? 5 times 6 is 30. So if I multiply everything by 30, I should be able to get rid of both brackets at once. So let's do that. I'm going to multiply every item in this equation by 30. So I'm going to have 30 times a over 5 minus 30 times a over 6 is equal to 1 times 30. Okay? Again, you have to multiply everything by 30. Every item has to get multiplied by the same thing. So on the right-hand side, I have 1 times 30. That's 30. On the left, I have 30 times a divided by 5. Or I can reduce 30 and 5. Well, 30 divided by 5 is 6. And in the second fraction, 30 divided by 6 is 5. So I'm left with 6a minus 5a equals 30. Now I can group my like terms together. So 6a minus 5a, that's going to leave me with 1a. So a is equal to 30. So this is what we just saw. When we have a variable that appears in more than one place, we want to collect those variables. Ideally, we'd like to do it sooner rather than later in our equation, if we can. Okay, so let's look at this question here. So I have 5g plus 4 equals 9g minus 16. So I want to get all the letters on one side, all the constants on the other side, all the numbers. It doesn't matter which side you put them on, you'll get the same answer either way. And in fact, I'll do this question twice just to prove that point. So I'm going to move all my letters on the left-hand side. So the 5g is going to stay where it is. The 9g, I'm going to bring it over here. I don't like using that term, bring it over there. What I'm doing is the opposite operation, right? So I'm going to subtract 9g from both sides. What about this 4? Well, that 4 I'm going to bring over to the right, or a better way of saying it is I'm going to subtract 4 from both sides. So I'm going to have negative 16 minus 4, like that. So all of my variable terms are on the left, all of my constants are now on the right, and we can simplify. So this becomes negative 4g, 5 minus 9, is equal to negative 20. And now it's a very simple question. We're just going to divide both sides by -4, and we get g is equal to 5. Now, like I said, it doesn't matter which sides you group your variables on. We could do it on the other side. Let me rewrite the question. I'll just show you. What if I wanted to put the g's on the right and the numbers on the left, right? So the 5g is going to come over here, so I'm going to subtract 5g from both sides. I'm going to bring the 16 over to the left, so it's -16, so I'm going to do the opposite. I'm going to add 16 to both sides. So I'm going to have 4 plus 16 on the left, and that's equal to 9g minus 5g on the right. So when I simplify this now, I get positive 20 is equal to positive 4g. You can see very similar to this step over here, except instead of 2 negatives, it's 2 positives. But ultimately, you're going to end up with the same thing, because I'm going to divide both sides by positive 4, and I get 5 is equal to g, or g equals 5. So again, either technique, either side you solve on is fine. All right, so that's where we're going to leave it. Lots to practice here, guys. This is one of those things we kind of want to skill and drill, lots of different questions to try it. What I want you to do as you're going through this, just remember the mantra we talked about. For every single question, we're doing reverse BEDMAS, and we're doing that in the opposite operation. All right, happy practicing. Email me if you have any questions. Good luck.